A single cell phone can contain up to half a gram of silver. Now imagine how much is in all the phones in the world. Silver is the best electrical conductor that exists. Without it, neither electric cars, nor satellites, nor your computer would work. A simple piece of jewelry can have more than 90% pure silver. But not everything sold is authentic. Do you know how to recognize it? The price of silver ranges around $25 to $30 per troy ounce, and a kilogram has approximately 32.15 ounces, so the value of a kilo of silver fluctuates between $800 and $960 depending on the market. Mexico, Peru, and China dominate global silver reserves. Do you know which country consumes it the most? Satellites, airplanes, and space rockets use silver in their components for its resistance and high conductivity. In several ancient civilizations, silver was considered more valuable than gold, as happened in ancient Egypt and Greece. Solar energy needs silver to function. Each solar panel contains several grams of this metal. Colloidal silver is sold as a natural supplement. Some claim it strengthens the immune system, but is it safe? If the world runs out of silver, many industries will come to a halt, from electronics to modern medicine. What's fascinating is that silver can be recycled infinitely without losing its quality, making it a valuable and sustainable resource. If all this surprised you, don't forget to subscribe, give it a like, and share this video so more people can discover the incredible world of silver. Stay with us for more fascinating content. Step 1. Exploration and deposit location. Silver exploration begins with the identification of potential deposits. This process involves a series of advanced geological techniques to locate mineral deposits in the Earth's crust. Geologists conduct field studies, seismic analyses, and geophysical surveys to obtain information about rock formations and soil composition. Remote prospecting methods are also employed, including satellite imagery and surface sample analysis, to detect possible mineral-rich areas. Once promising locations are identified, drilling is performed to obtain deep samples and confirm the presence of silver. These surveys allow determining the amount of silver in the deposit and the quality of the ore. The depth and size of the deposit are key factors in deciding whether the deposit is economically viable for exploitation. At this stage, the potential environmental impacts of extraction and the economic viability of the project are also evaluated. If the results are positive, the next phase begins, ore extraction. Exploration is essential to ensure that resources are utilized efficiently and sustainably. Step 2. Ore extraction. Once a viable deposit has been identified, the next step is ore extraction. There are two main methods for extracting silver from the earth: open-pit mining and underground mining. In open-pit mining, large amounts of surface earth and rock are removed to access silver deposits near the surface. This process is more common when deposits are relatively close to ground level. To do this, excavators, giant trucks, and explosives are used to remove layers of earth and rock. On the other hand, in underground mining, tunnels and galleries are built in the earth to reach deeper silver deposits. This method is more expensive and complex, but necessary when the ore is found at great depths below the surface. Miners use drilling machines and ventilation systems to ensure that the tunnels are safe for work. Once the silver ore has been extracted, it is transported to the processing plant to continue with the next stage: crushing and grinding. Extraction is a crucial step, as it defines the amount of ore that can be processed and, therefore, the profitability of the mining project. Step 3. Ore crushing and grinding. Once the silver ore is extracted, the next step is crushing and grinding. The objective of this stage is to reduce the size of the ore to facilitate the separation of silver from the surrounding rock. First, the extracted ore is placed in large crushers that break it into smaller fragments. This initial process, known as primary crushing, reduces the particle size and makes the ore more manageable. Then, the crushed ore moves to a grinding phase, where a mill is used to further reduce particle size, turning them into a fine powder. At this stage, ball mills or rod mills are used that grind the ore with the help of steel balls or metal rods, causing the disintegration of the rocks. Once the ore has been reduced to a fine powder, it moves to the next phase of the process, which is concentration and separation. This crushing and grinding process is fundamental to increasing efficiency in silver recovery, as it facilitates the extraction of the valuable metal and improves process profitability. Step 4. or concentration and separation. Ore concentration and separation is a crucial stage in the silver extraction process. In this phase, the goal is to separate the silver ore from sterile rock and other unwanted materials, increasing the concentration of the precious metal. To achieve this, several methods are used, depending on the characteristics of the ore. One of the most common methods is flotation, in which water and chemical reagents are added to the crushed ore. These reagents allow silver particles to adhere to air bubbles that are generated, separating them from the rest of the minerals and waste that sink to the bottom. The material that rises to the surface is collected as silver concentrate. Another method used is gravimetry, which is based on the weight differences between silver and other minerals. In this process, water is used to separate heavier particles, such as silver, from lighter ones. Once the silver has been concentrated, the material undergoes a cyanidation process, which uses a cyanide solution to dissolve the silver and further separate it from waste. This step is essential to obtain greater silver purity and prepare the ore for smelting. Concentration and separation allow optimizing the process, ensuring that the maximum possible amount of silver is extracted from the rock efficiently. Step 5. Smelting to obtain refined silver. Smelting is the process by which the silver concentrate, obtained in the concentration stage, is converted into refined silver. In this phase, the concentrate is heated to very high temperatures in a smelting furnace to separate valuable metals from impurities. The silver concentrate, which still contains unwanted elements such as lead, zinc, or copper, is placed in the furnace along with fluxes, which are substances like lime or borax that help melt impurities and facilitate their removal. Through intense heat, impurities separate in the form of slag, a layer of non-metallic material that floats on the molten silver, while the silver melts and is collected at the bottom of the furnace. Once the silver has been successfully melted, a silver ingot is obtained which, although it already has a high level of purity, may still contain small impurities. This ingot is prepared for the next stage of refining, in which it is further purified to guarantee the quality necessary for its use in jewelry, coins, or electronic products. Smelting is crucial, as it converts the concentrated ore into a material that can be worked and marketed as refined silver, ready for the next stages of the process. Step 6. Refining to purify silver. Refining is the final process to purify silver and obtain a high-quality product. Although the silver obtained in smelting is already quite pure, it may still contain small amounts of impurities such as copper, lead, or zinc, which must be removed to achieve a purity of 99.9% or more. There are several refining methods, but one of the most widely used is the electrolysis process. In this process, the impure silver ingot is placed as an anode in an electrolytic cell, while a pure silver cathode is used. An electric current is passed through a silver nitrate solution, which causes pure silver to deposit on the cathode, while impurities remain in the solution or in the form of slag. Another common method is fire refining, in which the silver ingot is mixed with acids that help dissolve impurities, leaving pure silver behind. This process is older but is still used in some smelters. Refining is essential to ensure that the final silver is of the highest possible quality, suitable for use in jewelry, coins, and especially in the manufacture of electronic components where high conductivity and purity are required. Step 7. Manufacturing final products. Once silver has been refined, the final step in the extraction process is its manufacture into final products. At this stage, pure silver is transformed into a variety of products, depending on its destination: jewelry, coins, electronic components, or even industrial items. For jewelry, silver is melted again and molded into specific shapes such as rings, bracelets, necklaces, and earrings. Goldsmiths or jewelry designers employ casting and modeling techniques to create detailed and personalized pieces. Often, silver is combined with other metals such as copper to improve its durability, forming alloys such as sterling silver. In the case of coins, refined silver is converted into ingots that are then stamped with designs and denominations. This process requires high precision and quality control to guarantee the purity and exact weight of each coin. For electronic products, silver is used in the form of thin films or wires due to its excellent electrical conductivity. It is employed in components such as connectors, integrated circuits, and screens of electronic devices. Finally, silver is also used in industrial products, such as machinery parts or components in photography. The manufacture of these final products marks the last step of a long and complex process that converts extracted silver into a valuable and useful material in a variety of industries. And so concludes the fascinating process of silver extraction and transformation, from its location in deposits to becoming jewelry, coins, and high-quality electronic products. This metal, so valuable and versatile, is key to many industries, and its extraction process involves a series of complex steps that guarantee its purity and functionality. Now that you know the path silver travels, are you surprised by what lies behind this precious metal? If this topic has interested you, don't forget to subscribe, give it a like, and share this video for more content about mining and natural resources.